platform, positioned about on the equator about 1,400 miles south of the big island of Hawaii. Our coverage of the launch of Eutelsat 3B spacecraft begins now. Welcome to our live coverage of the Eutelsat 3B mission. We're speaking to you from SeaLaunch Homeport in Long Beach, California, and in about 15 minutes, we'll be watching the liftoff of the Eutelsat 3B spacecraft from our equatorial launch site in the Pacific Ocean. This flight will be SeaLaunch's 36th mission and the first Zenit flight to take place in 2014. The Eutelsat 3B is the third spacecraft that we're launching for Eutelsat Communications, headquartered in Paris, France, and the third Eurostar 3000 spacecraft to be launched by SeaLaunch. The launch vehicle is ready for liftoff from the Odyssey launch platform, positioned in international waters. At the end of today's flight, the Zenit 3SL vehicle will place the Eutelsat 3B satellite into a customized geosynchronous transfer orbit for Eutelsat. The duration of today's flight is a little over 1 hour from liftoff to spacecraft separation. Operations are moving forward at the launch site, and all systems are looking good at this time. Liquid oxygen tanking is completed, and we should be able to see the liquid oxygen system venting from the integrated launch vehicle now. The external thermostating hoses that supplied cooling air for both the spacecraft and the rocket have been disconnected, and now the spacecraft is cooled by high-pressure air through the cable mast. The erector arm has lowered away from the rocket, and it will retract all the way down to the transporter. This transporter erector ground support equipment then moves inside the protective hangar for the remainder of launch operations. While the operation is underway, let's hear from Vitaly Lopota, Chairman of the Board of Directors of SeaLaunch and President and General Designer of the SP Korolev Rocket and Space Corporation Energia.
Уважаемые дамы и господа, дорогие гости 36-го пуска компании SeaLaunch с морского космодрома. Сегодня мы запускаем уникальный космический аппарат компании Eutelsat 3B. Этот пуск для нас всех очень важен. Впервые на геостационарной орбите должен появиться телекоммуникационный спутник с ресурсом работы более 15 лет. Eutelsat 3B будет предоставлять услуги странам Америки, Европы, Ближнего Востока и Центральной Азии. Международная кооперация предприятий нашего проекта делает все для его успешного запуска и надежного функционирования. Мы высоко ценим партнерские отношения с компанией Eutelsat и ее постоянную поддержку. Создателем запускаемого сегодня спутника является всемирно известная компания Airbus Defence and Space, наш давний и надежный партнер. Вспомним историю морского старта. В конце марта мы отметили 15-летие первого пуска, который состоялся в 1999 году. Пользуясь случаем, я хотел бы поздравить с этой датой наших партнеров и коллег, которые успешно обеспечивали и обеспечивают функционирование морского космодрома. Сегодня мы, как и всегда, уделяем особое внимание высокому качеству ракетно-космической техники и миссии в целом. По докладу директора миссии международная команда наших специалистов и все технические средства готовы к выполнению предстоящего пуска. Успешной нам работы и удачи всем участникам пуска Eutelsat 3B. Удачи!
That was Vitaly Lopota of RSC Energia. We're about 11 and a half minutes to liftoff as we look at a live shot from the Odyssey launch platform. As we anticipate today's launch, we have a remarkable video piece from our friends at Eutelsat. And that was a look at the Eutelsat 3B satellite. This launch marks a very special event in Africa. The rocket's fairing is decorated with an illustration by the 16-year-old Kenyan student, Eva Shemengoram, who was one of 2 winners of last year's DSTV Eutelsat Star Awards. Sponsored by MultiChoice Africa and Eutelsat, the DSTV Eutelsat Star Awards is a competition designed to spark interest in science learning by secondary and high school students across Africa. Eva and her mother Winnie are watching the launch today in Kenya, and we send them warm greetings. As we await liftoff, here are some welcoming remarks from Sergei Gukayev, president of SeaLaunch.
Good afternoon from our Launch Operations Center located at Homeport in Long Beach, California, and welcome to the launch of Eutelsat 3B spacecraft. Permettez-moi d'abord d'adresser nos cordiales salutations à nos amis d'Eutelsat à Paris, leurs clients ainsi qu'à nos collègues d'Astreum à Toulouse. I would also like to welcome the various space industry viewers, our invited guests here at Homeport and Bern, and space enthusiasts around the world watching our webcast. This is our first flight of 2014 and mission number 36 for SeaLaunch. As we near the terminal count for Eutelsat 3B mission, the entire SeaLaunch team is focused on the task at hand of delivering the spacecraft to its designed orbit. We appreciate the support and trust placed upon us by Eutelsat and look forward to many missions for the company going forward. Current weather conditions are optimal at the launch site, and I'm pleased to report that the launch countdown is progressing as planned and that all conditions are within our launch commit criteria. At this point in our launch operations, all our systems and teams are ready to go for a on-time liftoff. Today's launch is a 2-burn mission for SeaLaunch, with spacecraft separation occurring about 60 minutes after liftoff. So please sit back and enjoy the mission coverage. Thank you again for joining us. Go SeaLaunch! Allez SeaLaunch! Вперед, морской старт!
That was Sergei Gukayev, president of SeaLaunch AG, and we recorded his remarks earlier for tonight's mission. At just a little over 6.5 minutes, we're looking at a Zenit 3SL rocket ready for liftoff from the Odyssey launch platform to carry the Eutelsat 3B spacecraft to orbit. Built for Eutelsat by Airbus Defence and Space, this tri-band Eurostar 3000 series spacecraft will provide a total satellite power capability of 12 kilowatts throughout its designed orbital service life of 15 years. With up to 51 transponders, Eutelsat 3B will operate in C, Ku, and Ka bands. It will add resources in 3 frequency bands connected to fixed and steerable antennas for maximum flexibility. The spacecraft will provide uninterrupted service and additional capacity and capabilities to Eutelsat customers from Europe, Africa, Central Asia, and South America. That's a little over 5 minutes and counting. All systems are looking good for an on-time liftoff at 21:10 UTC GMT. Let's take a look at today's flight profile. From its ocean-based launch site located directly on the equator at 154 degrees west longitude, a Zenit 3SL launch vehicle will lift the Eutelsat 3B spacecraft into an optimized geosynchronous transfer orbit on its way to its final geostationary orbit at 3 degrees east longitude. The Zenit 3SL rocket will begin its ascent phase of the flight. The first stage of the vehicle will separate 2 minutes and 30 seconds after liftoff, and then the protected payload fairing will be jettisoned 81 seconds later at 3 minutes 51 seconds into the flight. The second stage will conduct a 6-minute burn, followed by its separation from the Block DM SL upper stage. The Block DM SL will begin its first of 2 burns at 8 minutes 41 seconds into the mission for the duration of 279 seconds. The upper stage will then shut down for a 30-minute, 30-second coast period, followed by the start of the second burn at 43 minutes, 50 seconds into the mission. Spacecraft separation is expected at 1 hour after liftoff over the Indian Ocean. And that's our flight plan for today's launch. We're now just a little bit over 4 minutes to liftoff and counting. The team in the Launch Control Center currently is making final reviews at this time. The Launch Control Center is located on the SeaLaunch Commander, now safely positioned nearly 4 miles from the launch platform. The platform was evacuated before fueling operations began a few hours ago, and all personnel are aboard the ship for the remainder of launch operations. The launch team is now currently progressing through the final countdown procedure, monitoring telemetry from the launch vehicle and the spacecraft to ensure all critical systems are nominal for launch. They're also keeping an eye on both of the vessels as well as the launch range to be sure all conditions are within our launch criteria. The Marine crews verify and hold their relative headings of the vessels to maintain orientation for launch. Our meteorologist monitors sea conditions in real time using data from the SeaLaunch weather systems at the launch site. And the launch team also monitors the winds aloft by releasing weather balloons at designated intervals prior to liftoff.
MD, SLOM.
Директор миссии РСЛ.
На связи. Go ahead. PLU is on internal power and is go for launch.
Бортовое питание БПГ включено. Есть готовность к пуску.
Принята готовность. Roger.
MD, MRZ. Директор миссии КМО.
На связи. Go ahead.
No third-party aircraft have been sighted per the LCC-65 hazard area.
Посторонних летательных аппаратов не обнаружено.
Dr. Valeria Leave, our mission director for today's flight, confirms that all systems are go for launch as the automated countdown continues. The weather for today's launch is good, and at this time, all environmental conditions continue to be within launch criteria. Our current temperature is 82 degrees, with seas running a little over 5 feet, and the winds running at 11 knots. All mission milestones are proceeding on schedule. The teams from SeaLaunch, Eutelsat, and Airbus are monitoring their systems before terminal count begins. At L-1 minute and counting, we are go for launch of the Eutelsat 3B satellite. Stand by for the terminal count, as you'll hear it in both Russian and English.
Объявляется минутная готовность.
1 minute readiness. Stand by for terminal count.
Последние секунды предстартового отсчета.
Ten,
10,
9,
9,
8,
8,
7,
7,
6,
6,
5,
5,
4,
4,
3,
Restart command.
2,
Go
1.
inertial. Liftoff. Main engine is at nominal thrust.
Директор миссии РС. На связи.
Again, pitch over. LV stabilization is nominal.
Liftoff command has been acquired.
LV stabilization is nominal. 20 seconds in flight. Propulsion system performance is nominal. Flight is nominal. ILV stabilization is nominal. ILV is now transonic.
Директор миссии РС.
Main engine pressure is
Точное время
nominal.
КТ. 21 час 9 минут 59 и 119 тысячных секунды по Гринвичу.
Flight is nominal.
21 час 9 минут 59 и 119 тысячных. Принято.
Maximum dynamic pressure.
Contact liftoff occurred at
ILV stabilization is nominal.
0 seconds. Correction, 0 minutes, 59 seconds, decimal 119.
Propulsion system performance is nominal. Contact liftoff time was 29:09:59 decimal 119. Flight is nominal. ILV motion is stable. Begin engine throttling for minimum acceleration. Flight is nominal. ILV stabilization is nominal. Final sequence of throttling. Flight is nominal. (170 seconds). Stabilization of launch vehicle is nominal. 180 seconds. Pressure in main engine and vernier engine is nominal. Flight is nominal. ILV motion is stable. ILV stabilization is nominal. Flight is nominal. PLF jettison command is sent.
Fairing separation brake wires are confirmed.
Pressure in main engine and vernier engine is nominal. 250 seconds. ILV stabilization is nominal. Flight is nominal.
Brewster Ground Station.
MCC and ACS confirm block DM telemetry.
MOC,
Brewster Ground Station confirms receipt
MOC,
of PLU down. Начать вертолетную инспекцию стартовой платформы.
Begin aerial inspection of the LP.
Roger.
Принято.
ILV axial load is nominal. Main engine and vernier engine performance is nominal.
На связи. Идет приведение ракетного сегмента в исходное состояние. Принято.
Sequence
ILV
4,
flight is nominal.
rocket segment is returning systems to the initial state.
Attention all personnel.
ILV stabilization
all
is
rescue
nominal.
members
We're now
must
5 minutes into the
report
flight of the Eutelsat 3B spacecraft, and the telemetry for the Zenit 3SL launch vehicle looks good. We've had confirmation of first stage separation and jettison of the payload fairing. The second stage engines will burn for roughly 4 more minutes, traveling above the atmosphere, and then it will separate from the Block DM SL upper stage. During this phase of flight, we will hear announcements for the operation of the main engine and the throttling down of this engine. This reduction of thrust allows for a safe shutdown of the main engine.
Main engine and vernier engine performance is nominal. Ground station is receiving LV telemetry. Flight is nominal. ILV stabilization is nominal. Pressure in main engine and vernier engine is nominal. ILV flight is nominal. Begin main engine throttling for maximum acceleration.
AC's ground confirms receipt of TDRS POU telemetry.
Main engine and vernier engine performance is nominal. Second stage main engine shutdown confirmed. ILV flight is nominal. ILV axial load is nominal. Vernier engine performance is nominal. Flight is nominal. ILV axial load is nominal. .500 seconds. Pressure in vernier engine is nominal. Second stage vernier engine shutdown is confirmed. Zenith block DM separation is confirmed. Axial settling thruster ignition is confirmed. Block DM sleeve adapter jettison is confirmed. Low gain antenna deployed. First block DM main engine start is confirmed. Block DM main engine pressure is nominal. Zenith block DM separation occurred at 21:18:26 UTC. Block DM burn 1 ignition time was 21:18:36 UTC. Block DM stabilization is nominal.
We have confirmation that the second stage is now jettisoned and the Block DM main engine will now be in operation for roughly 4 minutes. This first burn of the Block DM upper stage boosts the spacecraft into a stable parking orbit. Let's take a moment now to look at a short film from our friends at Airbus. The first burn of the Block DM continues. The Block DM is now accelerating with the Eutelsat 3B satellite at an altitude of about 130 miles or 210 kilometers and is now almost 1,800 miles downrange from the launch platform, heading east over the equator. The main engine of this stage generates nearly 18,000 pounds of thrust, and during this burn will consume more than 17,000 pounds of propellant. Like the first and second stages of the Zenit booster, the Block DM upper stage uses a clean mix of liquid oxygen
First, Block DM main engine shutdown time was 21:23:12. Block DM flight is nominal.
We just learned that the first burn of the Block DM upper stage was completed successfully. The Eutelsat 3B satellite and its upper stage will now coast in low Earth orbit for a 30-minute, 30-second period, after which the Block DM will ignite for a second time. During this coast period, mission managers will be observing the onboard systems of the Block DM and the Eutelsat 3B satellite as they travel over the equator. Team members will be monitoring telemetry in the Launch Control Center at the launch site and also support centers in Moscow and Seattle. SeaLaunch depends on the Block DM upper stage for all of its missions. RSC Energia builds this component and designed the Block DM SL that we use specifically for all SeaLaunch operations. The Block DM continues to provide excellent performance and has flown over 260 flights in various configurations. At the launch site, our helicopter is making aerial inspections of the launch platform and will soon deliver the red team to the vessel for closer safety inspection and securing. This red team will be making a determination that the platform is a safe environment for re-entry. About 6 hours from now, people will begin to repopulate the launch platform for post-launch operations. Our live coverage of the launch of the Eutelsat 3B satellite continues, and we're about 15 minutes into the mission, and the Block DM upper stage and the Eutelsat 3B satellite are coasting in orbit. The Block DM has successfully completed its first of 2 burns, injecting the satellite into a parking orbit. This orbit, and then a second burn of the upper stage, enables the delivery of the spacecraft to a higher orbital perigee height for the geosynchronous transfer orbit, which translates into a longer spacecraft lifetime. The spacecraft and the Block DM are now traveling in an easterly direction, taking the equatorial route across the Pacific Ocean, South America, and the Atlantic Ocean towards the African continent. The SeaLaunch mission design process is very flexible and allows the spacecraft to take full advantage of the Zenit 3SL's heavy lift capability. SeaLaunch works with each customer during mission integration to optimize the injection conditions that best suit the spacecraft's orbital needs. Our flight engineers, or our flight designers at Boeing, Yuzhnoye, and Energia work together to create a specific optimized mission profile that meets our requirements, or the requirements of each of our customer spacecraft. Once the spacecraft is built and delivered to our payload processing facility at SeaLaunch Homeport, launch preparations get underway. And here's what those launch operations look like. The Eutelsat 3B satellite, manufactured by Airbus Defence and Space, arrived at Long Beach International Airport on February 18th. The spacecraft was then transported to SeaLaunch's Homeport facility at approximately 2 a.m. on February 19th. It was brought directly to the SeaLaunch's payload processing facility, where it was tested, fueled, and encapsulated in the payload fairing. payload team transferred the encapsulated spacecraft on May 6th in what we call the payload unit from the payload processing facility to the SeaLaunch commander, where it was mated with the upper stage of a Zenit 3 SL launch vehicle. Earlier in March, representatives from Eutelsat, their customers, and Airbus signed the rocket in a ceremony held on March 26th. On May 11th, the fully integrated launch vehicle was transferred from the assembly and command ship to the Odyssey launch platform. This operation took approximately 4 hours. The following day, on May 12th, the rocket was rolled out of its protective hangar and erected on the launch pad. In its vertical position, the rocket was put through a series of mechanical and electrical tests that verified that all systems were in order. At the conclusion of these tests, the rocket was lowered into its horizontal position, returned to the hangar, and prepared for transit to the launch site on the equator. The launch platform departed home port on May 15th, and the SeaLaunch commander followed on May 19th. The two vessels rendezvoused at sea on May 22nd and soon began operations at the launch site at 154 degrees west longitude. The team ballasted the launch platform about 65 feet to its launch depth, and the countdown was initiated at L-72 hours. Yesterday, the rocket was rolled out and erected to a vertical position on the launch pad. After final tests and fueling, the SeaLaunch system was ready for today's launch of Eutelsat 3B. That's a brief look at some of our preparations that occurred at home port leading up to today's launch. At a little under 20 minutes into today's mission, we're nearly halfway into the coast period, with the Block DM upper stage and the Eutelsat 3B spacecraft are approaching South America, traveling directly over the equator. And if we can get a shot of the tracking map, we'd be able to see our relative position. They're taking the satellite to their optimum position for the beginning of the second burn of the Block DM upper stage. This is the Eutelsat 3B mission coverage coming to you live from the SeaLaunch home port in Long Beach, California, and from our launch site 154 degrees west longitude on the Pacific Ocean. Our team in the Launch Control Center at the equator is monitoring all of our systems, and they report everything is nominal at this time. The launch team continues to monitor the Block DM upper stage and the Eutelsat 3B satellite as they coast in a parking orbit over the equator. All operations are performing as planned. We're now a little over 20 minutes into the Eutelsat 3B mission, and all systems are nominal. The Block DM upper stage is coasting with the 3B satellite over the Atlantic Ocean. In about 15 minutes, the Block DM's main engine will ignite. Well, a little over 23 minutes, the Block DM main engine will ignite for its second burn. This operation will be about 6 minutes in length. The launch team is monitoring all of the systems of the Block DM upper stage and the Eutelsat 3B satellite during this coast period. All operations have been performing within acceptable parameters, just as planned. That's been the case throughout this mission. The upper stage and the satellite are now traveling about 250 miles or 400 kilometers above the Earth over the Atlantic Ocean. At the launch site, a small team is inspecting the launch platform to determine its safety for the personnel to begin transferring over from the SeaLaunch commander. We're anticipating the second burn of the Block DM in about 10 minutes. As we wait for that, here's a tribute to some of the people that made today's mission possible.
vaga, ça va voir. La va grave au java, va va, navez gueux. Qui vit, ça veut, fabouille, la vache à gat. En vent d'avant sa gant, le veut ou vous la gâte. C'est vec cavar ta gueule, la va moustagache. Cravoya gant congon, la va des vignavez gueux. Mais ve ça veut favé avant qu'ugu les gays. Et ve cravi ou vous, la va ou vous la va.
That was an amazing historical piece from RSC Energia. We're back and we're awaiting word from the Launch Control Center that the Block DM is starting its second burn of this mission. Let's listen in.
Block DM stabilization is nominal. Second Block DM main engine start confirmed. Block DM stabilization is nominal. Block DM burn 2 start time was 21:53:45 UTC. Block DM flight is nominal. Block DM main engine pressure is nominal.
We now have confirmation that the second burn of the Block DM upper stage is now in operation. The burn will last approximately 7 minutes. We'll be back for burn 2 after a short interview with Dr. Aliyev, SeaLaunch Mission Director.
Моя роль директора миссии состоит из 26 задач примерно. Эти задачи можно разделить на 3 направления. Первое направление – это ответственность директора миссии за выполнение всех операций технологического цикла подготовки комплекса «Морской старт» к пуску. Второе направление – это ответственность за выполнение критических операций, критических задач, таких как заправка космического аппарата, заправка разгонного блока, загрузка компонентами топлива стартовой платформы. И третье направление – это руководство и выполнение всех совместных операций с ракетой на комплексе «Морской старт» в базовом порту и в районе пуска. Сюда относятся операции и подготовки, и выполнения обзоров готовности, и проведение комплексных репетиций совместных операций, и проведение совместных операций в базовом порту, таких как перегрузка РКН на СКС, с СКС на стартовую платформу и выполнение заключительного цикла подготовки в базовом порту, сухой вывоз. И сюда же относится самая главная задача – это интеграция руководства пусковыми операциями в районе старта, выполнение графика этих операций и в конечном итоге выполнение пуска. Если говорить совсем коротко, то в ответственность директора миссии входит планирование операций, исполнение этого графика планирования, ответственность за безопасность персонала и оборудования и за успех пуска. Вот эти основные задачи являются предметом моей работы на текущей миссии.
That was Dr. Aliyev, Mission Director for SeaLaunch. He's had a long and illustrious career with the Russian space program and with SeaLaunch. The Block DM is now completing a 6-minute burn that puts the upper stage and the spacecraft into geosynchronous transfer orbit. We'll listen to the Launch Control Center for the latest word on the end of this second burn.
Main engine pressure is nominal. Block DM flight is nominal.
As you can see, all of our personnel on board the LCC Control Center are monitoring the situation of the spacecraft and of the Block DM operations as we anticipate the second Block DM burn.
Main engine pressure is nominal. Block DM flight is nominal. Block DM stabilization is nominal. Main engine pressure is nominal. Block DM flight is nominal. Block DM stabilization is nominal. Block DM burn 2 shutdown is confirmed. Block DM burn 2 shutdown time was 22:00:38 UTC. Block DM flight is nominal. All block DM systems performing nominally.
With the Block DM second burn now successfully completed, the upper stage will begin maneuvers in preparation for spacecraft separation during this 10-minute coast period. At this point in the mission, the attitude control system stabilizes the Block DM and the spacecraft, orienting them in a proper position for spacecraft separation. Then the Block DM issues a separation command to the payload adapter. SeaLaunch provides the appropriate spacecraft adapter and separation system to meet the customer's specific requirements. For this mission, we're using the low-shock 1194 VS clamp band separation system built for SeaLaunch by RUAG Space. The Airbus 3000 spacecraft will be separated from the Block DM by a set of springs specifically located to meet the customer's requirements. While these operations are proceeding in orbit, members of the launch team at the equator are monitoring telemetry from the onboard systems of the Block DM upper stage and the satellite, coasting over the east coast of the African continent towards the Indian Ocean. Also, at this time, operators at the Heart of Beastock ground station near Pretoria, South Africa, will track the first telemetry signals from the Eutelsat 3B until approximately 2 minutes after separation. Following that, about 10 minutes later, operators from the Land Earth Station near Kumsan, South Korea, will begin tracking the satellite to also acquire its telemetry signals. The spacecraft is coasting in geosynchronous transfer orbit with the Block DM upper stage, preparing for spacecraft separation in about 6 minutes and 30 seconds. As we mentioned, the Block DM will be orienting into the proper position to issue the separation command to the payload adapter. We're monitoring live audio from the Launch Control Center for word on spacecraft separation, so let's listen in.
All Block DM systems are performing nominally. Block DM stabilization is nominal. Block DM flight is nominal. All block DM systems are performing nominally.
The spacecraft is now coasting in geosynchronous transfer orbit with the Block DM upper stage preparing for spacecraft separation in about just a little under 2 minutes. As we mentioned, the Block DM will be orienting into the proper position to issue the separation command to the payload adapter. We'll be monitoring live audio from the Launch Control Center for word of spacecraft separation. Let's listen in. Block DM flight is nominal. ACS confirms Block DM spacecraft separation. Spacecraft separation occurred at 22:10:28. MCC confirms Block DM spacecraft separation. The Moscow Control Center has now confirmed that spacecraft separation. The spacecraft is now moving away from the Block DM upper stage. The Block DM performs a set of maneuvers to distance itself from the spacecraft to avoid any recontact or contamination. This is a routine maneuver for all SeaLaunch missions. Our final major event for tonight's mission will be spacecraft acquisition. Operators at ground stations at a ground station near Kumsan, South Korea, have their tracking dishes pointed at the horizon for the first signals from the Eutelsat 3B satellite as it coasts over the Indian Ocean. Hartbeespoort, South Africa, as well as Kumsan, South Korea, are the primary tracking stations that acquire radio frequency transmissions from spacecraft, indicating their general health, temperatures, accelerations, roll rates, and so forth. The team in the Launch Control Center is monitoring communications for word of spacecraft acquisition. We anticipate that Astrium will begin confirming this event with Dr. Valery Lev, our mission director, within the next few minutes. Once the ground station acquires a signal from the Eutelsat 3B spacecraft, operators will take control using onboard thrusters and the onboard attitude control. They will direct the spacecraft to its preliminary testing location and initiate activities required for solar panel deployment. When the test phase is completed, operators will move the satellite to its final orbital position at 3 degrees east longitude. Eutelsat 3B is now coasting in its transfer orbit that, at its apogee, is more than 22,000 miles, or about 35,000 kilometers. We're anticipating word of spacecraft acquisition at any time, so we're standing by for that news. The time of this milestone event is always estimated. It's a matter of the ground station tracking the satellite on orbit and then acquiring its signal as it gains line of sight when the satellite comes over the horizon. As we await this event, let's now go live to Gene Senura, the Senior Project Manager aboard the ACS. Gene's in our Launch Control Center at the equator. Gene, are you there? How are things progressing?
Yes, Casey, I'm here, and you can see that things are progressing great.
It is.
Everything has happened just the way it's supposed to. All the systems have been operating nominally. We have a great team here. Everything is perfect.
It's a picture-perfect launch. Gene, this is our second launch for Eutelsat in 15 months. What's it been like working on the 3B mission?
Well, it's always good to work with the customer, and SeaLaunch is unique in the fact that we sort of hold the customer hostage for a couple weeks on the LP and the ACS. We get to know them, they get to know us, and we build up a rapport and a real good team spirit here. So when it comes to the final event, the launch, we know each other, we know each other's moves, and there's excellent cooperation between all parties. So it's unique, it's fun, and it's rewarding when we see a launch like we had today of the E3B satellite.
So leading up to the mission today, did you encounter any challenges with 3B?
Well, yes. It's always a challenge when you have two ships that have to travel almost 3,000 miles to get to the launch site. When you have personnel in close quarters, when you're working in an ocean environment, it's always, I won't say difficult, but there's always challenges. But the unique thing about this is that we have a team that's so used to those challenges and so good at meeting those challenging, taking them head on and correcting all our problems and situations and making it work out just the way it worked out on this one. So, and that's what keeps it exciting, and that's what keeps it rewarding. Ultimately, when we see a satellite coasting over India like we have right now, and just waiting for spacecraft acquisition, it's always a good feeling.
So, Gene, what's happening right now on the LP as we await acquisition?
Well, we have members of the Marine crew and from the rocket segment who are going through the LP, going to various rooms, checking to make sure that there are no hazards, no gas leaks, no fires, that anything that might have been shaken loose as a result of the launch. One of the things that people watching this webcast can't experience is the power of the Zenith 3SL when it leaves the launch platform. We're 3.5 miles away, and the noise and the vibration come roaring across the ocean, and you can really feel the power. So on the LP, there's a lot of shaking going on, a lot of noise, so we have to just make sure that everything is safe before we start repopulating the LP. So those people go from room to room, from system to system, and they check everything just to make sure that it is safe.
Okay. Gene, do you typically go out on every mission?
Well, I don't go out on every mission, but I believe that this is my 17th. So I'm not anywhere near the top. We have had people that have been on all missions. We have had people that have been on 30-plus missions. So I'm sort of, I guess, in the middle. Somebody sitting right next to me is on his first mission, and he thought it was really, really great. When you go out on that first mission, it's really an adventure. So we love it. Even
with you having gone on 17 missions, and you just can't get complacent about any of it. I mean, it's still an amazing piece of technology.
Oh yeah, it's great. Yesterday during ILV rollout, one of the customers came over to the LP and he asked for a tour. So I took him from the top of the LP down to the pontoons, 22 meters underwater, and showed him everything. And at the end of that, when he came up, he said, just amazing, all the stuff that's there and all the stuff that works. And he was really, really impressed. Of course, he was a little scared when we were in the pontoons. He only told me afterwards that he was a little bit claustrophobic. So he was uncomfortable, but he didn't want to miss anything. So, yeah, it was great.
So as we await acquisition, can you tell us a little bit about how acquisition works?
Well, as you mentioned, there's ground stations that are looking for the satellite. The satellite is, in essence, trying to phone home and let everybody on the ground know that it's okay. And once we get that, then we know that the systems on board the satellite are functional, and the customer can start taking control of the satellite for follow-on operations. So it's an important thing, and as you mentioned, we expected to have acquisition something like between 10 and 13 minutes after separation. But from past experience, we know that it can happen very, very early, or sometimes we have to wait a little bit and sort of fill in the time while we're waiting for that phone call to go through. But I'm sure it will. It was a good launch. Everything was, as we say, it was 5 by 5 right down the pipe. All the parameters were looking good all the way. So the spacecraft should be healthy, and it'll let us know that it is.
So, as we're waiting for acquisition, can you tell us who makes the formal announcement? How do you find that out?
Well, the customer here is in touch with the ground stations, and once he hears that they have, in fact, received a signal from the satellite, he'll inform the people in the LCC, and I'll know because I'm looking through the window right into the Launch Control Center, and I'm sure people will be standing up and cheering. So I'll probably be the second person to know because he's right in front of my window here, and he's anticipating it just the way we are. So sometimes it's nerve-wracking. Like I said, sometimes it happens early, sometimes it takes a little bit longer, but it's all what we're waiting for.
So now that we have separation,
hey, well, I just got word, Casey. Just got word we have spacecraft acquisition.
Outstanding, outstanding.
Yeah, everybody's cheering. We're good.
We now have confirmation of spacecraft acquisition and a mission success. Let's go back to aboard the ACS and check in once again with Gene Senura.
Well, it was a successful mission. From the time that we left Homeport, the weather conditions here at the equator cooperated. All the systems aboard the ACS and the LP worked perfectly. We have a great launch team. So I'd like to thank the customer, Eutelsat, for this opportunity, to Airbus for building a great satellite, to all the people who work at SeaLaunch, to all our contractors, and to our families at home who are celebrating Memorial Day without us. We'll be back soon, and we're looking forward to seeing all of you.
Gene, I know that everybody here at Homeport is wishing you all congratulations and a safe journey home.
Thank you. We'll see you soon. We'll see you, well, the ACS will see you in about a week. The LP will take a little longer, but we'll get back. Thank you.
Thank you, Gene.
Bye.
This achievement marks the 36th mission for SeaLaunch, and I want to be the first to congratulate Eutelsat on their new satellite. It's now transmitting its first signals. I also want to congratulate Airbus Defence and Space on the deployment of Eutelsat 3B. To recap tonight's events, a three-stage Zenit 3SL launch vehicle lifted off from the Odyssey launch platform, positioned on the equator in the Pacific Ocean at about 2:10 p.m. Pacific Daylight Time. The Zenit 3SL vehicle successfully delivered the Eutelsat 3B communication satellite to geosynchronous transfer orbit. Operators at ground stations near Kumsan, South Korea and Pretoria, South Africa acquired the first signals from the satellite, marking the mission a complete success. This concludes our coverage of the launch of the Eutelsat 3B satellite. I personally like to thank all our teammates at sea and at Homeport and the families who support us. And thanks to all our partners and our suppliers for their contributions to this mission.
On behalf of all of us at SeaLaunch, I want to extend our thanks to all of our viewers for joining us for today's launch coverage and another successful mission for SeaLaunch. SeaLaunch continues to build a legacy, one successful launch, one satisfied customer at a time. For more information and images of the Eutelsat 70B mission, please visit the SeaLaunch website at www.sea-launch.com. I'm Brent Allen.